Okay. Okay. Okay, students, good evening. And can you confirm whether I'm audible? Quickly. Can you confirm whether I'm audible? We'll start. So can you quickly confirm whether I'm audible? Can you quickly confirm whether I'm audible? Students, quickly. Yes. Okay, thank you. Right. So good evening again, and we'll start. We'll start. Then for now, still it seems some students are joining in. So anyway, I'll wait 2 more minutes, and meanwhile, what you can do is, I have uploaded the study material today, the tube today, for the discussion to my Telegram channel. So what you can do is you can go there and download it, and I have pin a comment in the chat box, and from that you can go there and download it. Right. So if you are already in the Telegram channel and other WhatsApp groups, you can get the route from them as well. I mean the link through that as well. Or else I have pinned the comment in the chat box here. So just go there and download it. That will be the tute. That will be the study material for the discussion today. Right. So I'll start in 2 minutes. So during that 2 minutes, you can quickly download it and get ready. Right. Please download it and get ready. Get ready with your tute. Okay. Download the tute and get ready. And if there's anything wrong with the live, if there's something if there's something which goes wrong when the live starts, if that's a quick thing, you can quickly drop me a message to my personal number, because if I was on the board, sometimes I might not see the chat box, right? So therefore, if there's something urgent, if something wrong happens with the live, right, quickly drop me a message to my private number, right? Okay, we'll start. For now, there's no issues, no? Okay, I hope you have downloaded the tute, right? I hope all of you have downloaded the tute. So there you can see there are a set of MCQs and structured essays with essays, right? So today we'll start off with an essay, right? We'll start off with an essay, right? So before starting, the reason to have this kind of a discussion is because for most of the 2026 students, your second term exams are going on now, right? And there were some schools, they have already had their term tests, and in most of the schools, term tests are upcoming in the next week, right? So that's why I had to take this session today, and this was the only free time I had during the week. So that's why the reason to conduct this as a night seminar, to get you something out of this, and to give you something out of this that will support you in your term test, right? So you will recall the things in the syllabus. I mean, you will recall some theory parts with me when we are discussing questions, and you will practice writing questions here, because all these questions are targeted questions for your term test, second term test, right? Structured essay writing, MCQ writing, and that idea will be given. So by the end of the session, right, by the end of the seminar, even though if you don't have any idea about how to write answers for a structured essay question, for an essay question, right, and if you don't know the techniques of picking answers for MCQs, right, by the end of this seminar, definitely you will get something, you will know something about how to tackle such questions, right? So therefore, since this is going to be a night seminar, now we are starting at 10, and this will go around 2-3 hours. So therefore, first be comfortable with yourself, which means now if you need a water bottle, and if you need, let's say, some snacks during the session, or if there's something like that, don't go there and come back to the session again, because you will miss some parts, right? So I'll continue this session starting from now. So therefore, what you can do is you can make yourself comfortable now, right? With if there's anything that you need during the discussion, right? And always please engage with me when the discussion goes. Please do engage with me, because now this is a fully online discussion, and I'm just talking to a camera here. I'm alone here and alone in the room and talking to the camera. So therefore, please engage with me from the chat box, because then I know that you are listening, right? Otherwise, talking alone to a camera for 2-3 hours in this time is so not an easy thing to do, right? Not an easy thing. So therefore, please engage. Please engage with the session when the session goes on, right? So then you can get the maximum out of this when this is an engaging session. So you have to involve. All right. So go to question number 3, essay question number 3 in page 11. Go to essay question number 3 in page 11. It starts as, consider a situation where a motor car A with an engine trouble is being pulled by a breakdown truck B, right? So go to that, go to question 3. And first, before I start, I'll give you 3 minutes to start from your end, right? I'll give you 3 minutes, just 3 minutes to start from your end. Start question number 3. I'll mention here. Start question number 3 in page number 11, right? Start question number 3 in page number 11. Start question number 3 in page number 11. Start question number 3 in page number 11. Start it. Start the question. Okay. Question number 3, page number 11. That is a mechanics question, because for term 2, we'll be getting the majority or the most of the questions, majority of the questions from mechanics, from mechanics. And in some schools now already waves might have just started, right? So unless otherwise, from target questions, the majority of the questions will going to be from mechanics, right? So start question 3. That's a mechanics question. And always engage with the session. Engage with the session. All right, let's see. Consider a situation where a motor car A with an engine trouble is being pulled by a breakdown truck B on a flat road as shown in the figure 1. The masses of vehicle A and vehicle B are 1000 kilograms and 3000 kilograms respectively. Assume that the resistive force acting on each vehicle against their motion is given by 4 newtons per kilogram, right? 4 newtons per kilogram. Sketch a diagram of the vehicle A on your answer sheet and draw the forces acting on it when the vehicle B is pulling the vehicle A with constant velocity of 10 ms minus 1. Okay. A force diagram for capital A, right? So let's say this is capital A, right? Capital A. And here there's a string with a tension, right? So I'll mark the total reaction. This is part A. This is part A of the question. Resultant reaction as R. Let's say RA. I will mark the resultant reaction as RA. And there's a weight. So I'll mark that weight as 10,000 newtons. And there will be a tension of this string, let's say T. And there will be a resistive force. Resistive force, if there is 4 newtons per kilogram, here it should be this 1000 kilograms, no? 4000 newtons. This is 4000 newtons. 4000 newtons, right? B. Calculate the forward total force applied by the vehicle B. Calculate the forward total force. Calculate the forward total force applied by vehicle B. Right. Now it says the car travels with a uniform velocity. Right. It says the car travels with a uniform velocity. Right. Acceleration equals 0 since uniform velocity. Acceleration equals 0 since uniform velocity. Right. So therefore, what you can do is, now the total force applied, that's not what it's asking. Calculate the total force applied by B. Okay. Then we can use a system, not just A, we can use a system, right? What I'm doing is, for system, use F equals MA. For system, right hand side, use F equals MA. Let's assume the total force applied by vehicle B as F, right? Then it should be, let me draw the force diagram if you need, right? Let me complete the force diagram. Here they ask this lorry. There is this lorry, the breakdown truck, T. And for that also there are reactions RB, and this is the forward force applied by the truck. And on the truck also there will be resistive forces. That will be 3000 means 12,000. 12,000 newtons, and the weight here is 30,000. 30,000 newtons. Right? Now I'm going to consider the whole system. Whole system. Considering the whole system, we can use F equals MA. Considering the whole system, we can use F equals MA. Right? Then tensions cancel each other. Then F minus 12,000 minus 4,000 equals, since A is 0, product MA is 0. Since A is 0, product MA is 0. So F will be 16,000. F will be 16,000 newtons. Right? Calculate the total forward force. Calculate the total forward force applied by vehicle B. I consider it as F, that is 16,000 newtons. 16,000 newtons. Right? So please engage with the session asking questions. Right? I told you. And see, what's the power of vehicle B? Part C. What's the power of vehicle B? So we know power is FV. P can be written as FV. FV is 16,000 here. And V was 10 ms minus 1. 10. Which means this can be written as 16 times 10 to the power 4 watts. That is 160 kilowatts. That is 160 kilowatts. Part D. What's the tension in the cable used to pull the car in this situation? What's the tension of the cable used to pull the car in this situation? Right? Now, if I need to get the tension, I'm going to consider only A. Right? This is B. No, I'm going to consider only A. Right? For A, use F equals MA again. Still A is 0. Still A will be 0. Only F remains with A is capital T. Sorry, T minus reaction, T minus resistive force, T minus 4,000 equals 0, which means T equals 4,000. T equals 4,000 newtons. T equals 4,000 newtons. T equals 4,000 newtons. E. If the force constant of the cable is 40,000 Nm minus 1, calculate the extension of the cable. E part 1. We'll do here. E part 1. Right? So we know from Hooke's law, F equals Kx. F equals Kx, where F is force, K is force constant, spring constant, or it is called elastic constant. X is extension. Right? Now F is 4,000. That is found already 4,000, and K is given 40,000. X. So which means X equals 0.1 meters. Part 2. Calculate the strain energy stored in the cable. The strain energy, equation of strain energy is half Kx squared. Right? So if you don't know the equation, the strain energy equals half Kx squared. Strain energy equals half Kx squared. Right? So let's say strain energy is E. SE. Half K is known, 40,000. X squared. 0.1 means 10 to the power minus 1. No? Then 10 to the power minus 1 squared. Right? 0.1 is 10 to the power minus 1. 10 to the power minus 1 squared. So see, simplify this. Simplify this. Here we have 10 to the power minus 2. It cancels here. 400 over 2, 200 joules. 200 joules. 200 joules. Ask if there's anything. Now we are in part F. We are in part F. If the maximum tension that the cable could withstand is 6,000 newtons, right? Determine the maximum acceleration that the car could be pulled, right? Now, for now, if you check the value, at present, the tension of the string is 4,000, right? At present condition, tension of the string is 4,000. Now it says the maximum tension is going to be 6,000, right? So in that case, what we can do, again, we can use part F. Again, we can use F equals ma for A by considering A. See, for A. Now I'll consider the maximum tension of A as T max. Rightwards F equals ma again, right? Then only rightward force with A is, now this is the force frame of A. This is the force frame of A. This is the force frame of A. So let's say the maximum tension as T max, right? T max is given, that is 6,000. 6,000 minus 4,000 here. 4,000 and M of the car is 1,000. 1,000 A. Simplify this, very straightforward. 2,000 equals 1,000 A, which means A equals 2 ms minus 2. A equals 2 ms minus 2. Right. So we have completed first 5 parts, A, B, C, D, E, F. 6 parts. Right? Yeah, 6 parts. Any questions up to here? Any questions? You can ask if there's anything. What questions in on right? මෙතන questions ගොඩක් තියෙනවා අපේ අද discussion එකට. ඉතින් ඒ නිසා මම පොඩ්ඩක් speed කරගෙන යනවා පේනවනේ. ඒ questions තුනක් තියෙනවා, structured තුනක් තියෙනවා, MCQs 20ක් තියෙනවා. So there are few more questions, quite a lot of questions. So therefore, if there's anything, please ask, and even if it's clear up to here, say it's clear, right? Session එකත් එක්ක engage වෙන්න. I'm just talking to the camera by I'm alone here and talking to the camera, right? So please engage with the session. Then I know that you are on the track. All good? හරිද? හරි. So up to here, මොනවා හරි questions තියෙනවා නම් you can ask. So if there's anything to ask up to here, please ask, and if that's clear enough, just say it's clear. Right? Session එකත් එක්ක හොඳට engage වෙන්න. The reason is මේ රැ වෙලා තනියෙන් කැමරා එකක් ඉස්සරහා කතා කරන එක ලේසි නෑ. Right? That's not easy because I'm just talking alone to the camera, right? recording video එක බලනවට වඩා කතා කරන එක මෙතන අමාරුයි, right? Now unless it's unlike a physical class. Now in a physical class, now there are physical students, so I can see whether they are doing or not, and some interaction is there. Now here there's no interaction, I'm just talking to the camera, so that's why I'm keep saying this, keep asking this. If it's clear also, say it's clear. Right? Use the chat box, please. Is it all good up to here? Right, next part, I'll be raising this. Next part. Now, the front wheels of the vehicle A are raised by attaching one end of the cable of the hook. Give a second. One end of the cable of the hook of the crane located in the vehicle B as shown in the figure 2. The vehicle B pulls the vehicle A with a uniform velocity. When the vehicle A is at this new position, the cable makes an angle 30 degrees to horizontal. The resistive force acting on the resistive force acting on it is decreased to 3825. Okay, it's decreased. And the resistive force acting on the vehicle B increases. Diagrams are not shown to the scale. In this situation, what's the tension of the cable? Tension in the cable. Take root 3 as 1.7. Right. Take root 3 as 1.7. Now the case is different. Now the force diagram is going to be different. Right. Force diagram is going to be different. See. Force diagram is going to be different now. We are in part G, right? Force diagram is going to be different now. This makes an angle 30, right? So let's say this is A. Now this makes an angle 30 with horizontal, right? And it is attached to this truck from here. Okay, it is attached to the truck, the breakdown truck, the truck. Okay, from here, that is B. All right, now some distance is also given, right? Distance is also given. Now this is on ground. This is on ground, and this resistive force, it says it decreased to 3,825 newtons. 3,825 newtons. Right? This is my A. Right? They are asking the tension. They are asking the tension. Now, since there is an inclined tension, I'm going to dissolve this. Right? Since there is an inclined tension, I'm going to dissolve this. Away from the angle, we have T sine 30 from T, and towards the angle, here we have T cos 30. T cos 30. Now, still, it says the vehicle travels with a uniform velocity. Right? It says the vehicle travels with a uniform velocity. Right? So, we can do the same thing. We can do the same thing. For A, F equals ma rightwards. Right? Now, if without applying F equals ma, if you write the horizontal equilibrium at once, because if acceleration equals 0, there is actually a horizontal equilibrium. Right? If you consider a horizontal equilibrium at once, that is also totally fine. Now. So, I use the equation for all of you to understand. Otherwise, if you use the horizontal equilibrium at once, that is totally fine. That is totally fine. F will be T cos 30, minus this equals 0. So, which means T cos 30 equals 3,825. We know cos 30 is root 3 over 2. Then T equals 3,825 over root 3 over 2 times 2. Right? And root 3 is given. Value of root 3 is given as 1.7. 1.7. 3,825 over 1.7 times 2. Have to simplify this. And this cancels with 17. Right? Definitely this cancels with 17. Three thousand eight hundred twenty-five over 17 is 225. 225, which means this is 2,250 and that times 2 is 4,500. This cancels, huh? This cancels. Next. That's a good part. In the second part, that's about the top plane. That's about the top plane of the vehicle. That's a good part. I'll erase this. Now take it down if there's anything. Okay, part H. Yeah, in part H. So if we need to show that it's not going to topple, now always such things are proved by using force moments. Because the logic is, if something is rolled or if something is toppled, the force moment in that particular direction has to be greater than the force moment to the opposite direction. Now, if there is not toppled to that direction, which means the force moment is less than the opposite force moment, right? So now we will check force moment separately and going to argue whether it's going to be toppled or not, right? Now, if you identify the point of rotation, this is called the point of rotation, no point of toppling here in this question. Point of toppling is going to be this. Point of toppling is going to be this, right? Let's say point of, because when this side gets heavier, right? I hope it's clear. When this side gets heavier, right? With this force moment, this truck can be toppled, can be rotated only around this point. Let's say point O, right? So therefore, now what I'm going to show is force moments about that point O are not equal, and if there is not going to topple, this force moment has to be less than the opposite force moment, right? That's why these distances are given. See, this is 3 meters. This wheelbase is given 3 meters. And from here to here, that is given as 0.8 meters. And this height is also given 1.2 meters. All right. All right. Now, for this tension also, there will be components, no? Right? For this tension also, there will be components. There will be components like this. If, if this is 30, this angle is also 30. So this is T cos 30. And this component is T sin 30. Okay. Now, let's take the rightward force moment about tau. First, rightward force moment is due to mg of this. I haven't marked mg of the truck yet. See, mg of the truck is, it says here, it says, assume that the line of action of weight of the vehicle be at right in between the wheels of the vehicle B. So that is here, right in between wheels, and it was 3000, which means 30,000. 30,000 newtons. It was 30,000 newtons. 30,000 newtons. Right? 30,000. Okay, now we can write this force moment. Rightward force moment is only due to mg, 30,000. 30,000 into the acting line here is 3 over 2. 3 over 2. Right? Which means 45,000 Newton meters. And similarly, we can check the opposite force moment. And there are two forces which contribute the leftward, not leftward, the counterclockwise force moment. They are T sin 30 and T cos 30, right? So that is going to be T sin 30 times perpendicular distance is 0.8 plus from T cos 30 times perpendicular distance is 1.2, right? T is no 4,500. I will take it out and substitute these values. T is 4,500. Sin theta is half times 0.8, and cos 30 is root 3 over 2, 1.2. Have to simplify this. 4,500, and this is 0.4 plus this 2 and 1.2 cancels, 0.6, no? And root 3 is 1.7. It was given. It was given. Then we have to get 1.7 times 0.6. That is 1.02. 1.02. So therefore, this is 4,500 into 1.42. A small simplification is there. 4,500 into 1.42. 6,390 Newton meters. 6,390 Newton meters. Okay. Now we can state our arguments. Now we can state our argument that the leftward force moment, I'll write here, sorry, counterclockwise. My argument is counterclockwise force moment is less than, not greater than, if that is less than the clockwise force moment. Therefore, B is not toppled. Therefore, B is not toppled. Because if it is to be toppled, in order to be toppled in this direction, right, that particular force moment should be higher, should be greater. Right? Now it's less, which means it is not going to topple. That's a good question with a kind of a good thinking. Huh? That's a good question with a good thinking. Can you explain H again? H means this one, right? In physics and maths also, if we are arguing on something like a rotation, rolling or toppling, falling, something like that, about a point, the condition to be satisfied for that is the respective force moment on that direction, along that direction, has to be greater if there is rolled in that direction or if there is toppled in that direction, right? Now, as an example, let's say I need to topple this pen in this direction. I need to topple this pen in this direction. So, in order to topple this, in order to roll this in that direction, this force moment in that particular direction has to be greater than the opposite direction, right? That's the same argument I used. Right? Force moments. Because force moments decides whether an object is going to be toppled or not, whether an object is going to be rolled or not, right? So in the theory class, we discussed this as rolling questions in force moments, right? That's a perspective part. That's a particular part. Alright, अभी force moments वाली में type A questions discuss कर लेते हैं as rolling questions. Any other questions? If there are any other questions, please ask. It's clear now, right? The one who asked the question, Hafil. Yeah. Now we are in the last part, I. We are in the last part, I. We'll do that there. Okay, it says explain giving reasons as to why the resistive force on vehicle A decreases and the resistive force on vehicle B increases. Now, from your side, what you have to know is, right? From our side, from your side, what you have to know is this resistive force is a friction force. That's a frictional force, right? Resistive force actually because there is a resistive force between tires and the road. So definitely there is going to be a friction force. So everybody knows that friction is mu r, F equals mu r. So therefore, mu remains same here because same tires and same surface. So nature of the surface remains same, which means mu remains same. Then reason to this decrease and increase has to be with the reactions. Is it clear? So from that you have to argue. See, if I argue using A, for A, let's say initial reaction was Ra. Initially, this is initial case. Initially, let's say Ra. Initial, we know that was a vertical equilibrium, right? Initially, it was on a flat road. That was a vertical equilibrium, which means Ra equals 1000 means 10,000 newtons. right? And if I get the final value, let's say RA dash, that is here, RA dash, that is here, and this is also 10,000. Now, if I write a vertical equilibrium here, see, now if I write a vertical equilibrium here, second scenario, RA dash equals RA dash plus there's another force coming from here, T sine theta times sine 30 plus T sine 30 equals 10,000, right? Now find out RA dash from here. RA dash equals, now T is 4,500 and sine 30 is half, which means that is 10,000 minus 2,250, and that is going to be, look at here, that is going to be 7,750. Can you see? The reaction has decreased. Once the reaction decreases, now according to F equals mu R, that decreases. Now my logic is this. See, logic is this. Reaction on capital A decreases. Therefore, resistive force of friction, we can say, resistive force decreases according to F equals mu R, because when R decreases, F decreases. See, this has to be the complete answer. This has to be the complete answer. This has to be the complete answer. This has to be the complete answer, right? Now you can do the same. For B as well. They ask whether A decreases and resistive force on vehicle B increases. Correct? Now about vehicle B also, we have to do something. Same thing. Again. Now this is for B. Right? Initial, let's say RB was, they were on the flat surface, so that is 30,000, right? And if you need to find the final, right? Now this is RB dash final, RB dash. Upwards we have RB dash. Downwards we have T sine 30 comes from here. See, T sine 30 comes from here. T sine 30 plus what? 30,000. T sine 30 plus 30,000. Right? Then T 4,500 sine 30 half 30,000. Simplify this. This will be 32,250 newtons. Again the same argument. Now the reaction on B has increased. When the reaction on B increases, resistive force increases. Right? May argument B to match කරලා ලියන්න. මේ argument එකම B to match කරලා ලියන්න. Same argument එකම B to match කරලා ලියන්න. Write the same argument as to match with B. Right? So what you can say? Reaction on B increases. Therefore, resistive force increases according to F equals mu R. According to F equals mu R, because now we know this is an increase. Initially it was 30,000 and now it's 32,000 something, right? So when that increases, see, when the reaction increases, F increases. This is the final answer. This is the final answer. So that's a good question, no? With few thinking parts. That's a good question with few thinking parts. Okay. Doubts. What about the first essay question we discussed? Right? What about this first essay question we discussed? The first essay doubts. And if there is clear enough, clear done. Students, hurry, clear. Hurry, essay question ne kar lega right? Clear. Quickly. මේ type එකේ question එකක් mechanics වලින් most probably you can get most probably you can get අපි Bernoulli නෙමෙයි we'll discuss a question from hydrostatics as well. Archimedes theorem question එකක් discuss කරමු. මේක තියෙනවා එකක්. Right? Archimedes question එකක් discuss කරමු. Most probably Archimedes question එකක් එන්නත් පුළුවන්. Bernoulli එකක් එන්නත් පුළුවන්. Let's see. Right? Is it clear? First one. Quickly. again. I need your answers. Students, I need your responses. I need your responses to carry on. Okay, no questions now? Clear? Right. Okay. essay එකක් කරපු හින්දා ආයෙ essay එකක් කරන්න කලින් කම්මැලිකම යන්නත් එක්ක MCQs ටිකක් කරලා එමු, right? To break your ice, let's do some MCQs and come back to the essay again, right? Try first 5 MCQs. I'll give you 5 minutes. Try first 5 MCQs. First 5 MCQs टिक try करा. Try first 5 MCQs. Try first 5, 1 to 5. Try 1 to 5 MCQs. Start now. Try 1 to 5 MCQs. Start now. And meanwhile, ask if there's anything. Okay. Okay. Shall we see? First 5 MCQs. I ask you to do first 5 MCQs. First 5 MCQs. What are your questions if there's anything? Huh? Hurry. Shall we see? Shall we see? First one. Which of the followings have same units of force into time? Right? Have same units of force into time. Now, if you know known equations, now you can argue with equations. If not, you have to go to dimension and check it out. If you know an equation, that will be easy, right? So we know impulse equals, this is a very popular equation, no? I equals Ft, and that equals delta mv. So this is a single equation we have in uh, linear momentum. So therefore, force into time has impulse and momentum, A and C. Right? Very straightforward. This is impulse. This is linear momentum, LM, linear momentum. Right? Impulse and momentum, A and C, only A and C. For 1, answer 3. Right? I'll mention the answers here. For question 1, that is answer 3. For question 1, answer 3. Very straightforward. Second one, consider following statements made regarding zero error of a vernier caliper. Zero error of a vernier caliper. Zero error depends on the measurement taken by the instrument. No, because if that's a given zero error, let's say now for a vernier caliper, we have a zero error of 0.02 millimeters. Irrespective of the measurement, that same 0.02 millimeters will be there in each reading, right? So with the measurement, what changes? Percentage error and fractional error, right? Percentage error and fractional error changes with the reading because equation of percentage error is least count over reading into 100%, no? So that changes with the reading, but zero errors are not going to be depending on the readings. Zero error depends on the measurement taken by the instrument, wrong, right? Second one, A is wrong. A is wrong. B, zero error can be omitted by taking several readings for a measurement. No, zero error cannot be omitted. By taking several readings, what we can omit is the random error, right? What we can omit is the random error only. Zero error එක හැම ගන්න reading එකේම තියෙනවා. It will be there in each and every reading you take from that instrument, right? Zero error cannot be omitted. Zero error can be omitted. It cannot be omitted. So B is also wrong. Zero error cannot be omitted. Can be omitted taking several instruments? No, that's wrong. Zero error should be added or subtracted from reading accordingly to make corrections. It's correct. It is correct. C is correct. Now, if that's a positive zero error, we have to do a negative correction. If that's a negative zero error, we have to do a positive correction, right? Negative correction means subtraction and positive correction is an addition, right? Add kalla hari subtract kalla hari zero error එක අපිට අයින් කරලා correction එකක් කරන්න පුළුවන්. We can do a correction by removing the zero error by doing a positive correction or a negative correction. So therefore C is correct. Only C. Only C. For 2, answer 3. For 2 also, answer 3. Right? For 2, answer 3. Third one. The relationship between angular acceleration alpha, angular displacement theta and time t is given by theta equals k alpha t squared. 3. Theta equals k alpha t squared. dimensions of k is, okay, dimensions of k is, let's see. If I consider dimensions here of this equation, right? Dimensions of the equation, theta is angular displacement, no? That is an angle. There is no dimensions for an angle, so that is 1. If there are no dimensions, write it as 1. And dimensions of k, dimensions of alpha is t minus 2. Dimensions of t squared is t squared. So these two cancels, which means k equals 1. 1 means dimensionless. 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 No dimensions. For 3, answer 5. For 3, answer 5. No dimensions. Question 4. Centripetal acceleration is f of an object travels with uniform angular velocity omega. The correct variation between omega and f is. We discussed about graph plotting separately using a separate session as well. So this session එකේ හිටියනම් මේ graph එක අනිවාර්යයෙන්ම අඳින්න පුළුවන්. Right? මම කරපු graph plotting session එකේ හිටියනම් මේ graph එක for sure you can plot down. Centripetal acceleration. Centripetal acceleration is f කියලා මේගොල්ලෝ දෙන්නේ. So centripetal acceleration we know is r omega squared. Centripetal acceleration is r omega squared. We are going to plot omega. Subject omega. Omega squared is f over r. Right? Then omega is, let me split this, 1 over root r and root f. Right? Now this is going to be f is x, no? F is x. So this is root x. And this is my gradient. And this is y. So y equals m root x. What's the shape? Y equals m root x. Very popular shape. Omega with f. Omega with f. M root x. Answer 3. 4, answer 3. Okay. M root x is a standard curve. Standard curve. Now we have discussed. Right? Graph plotting ගැන තාම දන්නේ නැත්නම් මගේ YouTube channel එකේ වීඩියෝ එකක් ඇති graph plotting for A-level physics කියලා. අන්නේ live video එක බලන්න ඒ session එක බලුවා නම් ඕනේ graph එකක් plot කරගන්න පුළුවන් knowledge එක එතන තියෙනවා. Right? ඒතර මේ අදලා තියෙන්නේ මේ විදියට. Right? So we have to know plotting graphs. So if you don't know yet how to plot graphs like this by identifying variables, please watch that video on my channel that is under graph plotting. Right? 5. A washing machine is operated with a motor of 320 watts and the rotating disc of it has a moment of inertia 5 kgm squared. Starting from rest, how long will it take to acquire a frequency of 240 rpm under the above power? Phi squared equals 10. So we can consider phi squared as 10. Right. Okay, now from rotational motion we know, see, for linear motion as we have P equals Fv. See, as we have P equals Fv for linear motion, so we can convert this rotational motion as P equals torque omega. Right? අපි මේ equations කතා කරලා තියෙනවා ඊයේ class එකේ. P equals torque omega. So P is 320. I need torque here. And we know omega can be written as, now RPM is given, no? 25 RPM over 60. Omega is 25 RPM over 60. Right? We'll simplify phi later. Then this will be 25 RPM has given. RPM is 240 over 60 කියලා ලියන්න පුළුවන්. Simplify this. 320 equals, now this is 60 times 4, right? So that is torque times 8, 5. Okay, then torque again on 320 kg, 8 times 40, then 40 over 5. Torque here is this torque 40 over 5. Torque is 40 over 5. Now if torque is known, then you can use torque equals I alpha. I is also given and get alpha. Now I'm going to use torque equals I alpha. See? Now I can use torque equals I alpha. Having this in hand, torque equals I alpha. Torque is 40 over 5. I was given 5 alpha, and 5 and 40 cancels, no? So alpha equals 8 over 5. Now alpha is also known. Time how long it will take to acquire that frequency, starting from rest, right? How long time so apply omega 2 equals omega 1 plus alpha t. Omega 2 equals omega 1 plus alpha t. Okay. Then omega 2 equals omega 1 plus alpha t. Omega 2 equals omega 1 plus alpha t. Omega 2 is here. What's the value? Omega 2 minimum 25 240 over 60. Omega 1 is 0 and alpha is 8 over 5 t. This is 8 5. 6 to 4 cancels. Again, 8 5. 8 5 equals 8 over 5 t. 8 to 8 cancels. See, t equals 5 squared. Which means 5 squared is 10 kilo 10 seconds. T equals 5 squared. So they have given us to consider 5 squared as 10. You know? 5 squared can 10, answer is 10. For 5, answer 5. For 5, answer 5. See, a good application, a tricky question from rotational motion. Rotational motion. Any questions? Hari, MCQ pahagut hari. MCQ pahagut discuss kar lega. Any questions? Any questions? Is it clear up to here? Takala message jadda. Takala message jadda chat box ekada. Is it clear up to here? Takala. Clear? Hari. Now let's go to another essay. Okay. Again, I'll give you just 3 minutes and I'm going to start. Hari. Loko wela denna mang godakma discussion එක තමයි focus කරන්නේ. Right? Discussion එක focus කරන්නේ and I will recap the theory parts that you need and that you might need with the questions. Right? Theories මේවා මතක් කරගන්න. Right? So you can recall the theory parts, recall the parts needed along with the questions itself. Right? Go to target essay 1. Go to target essay 1. Go to target essay 1. Target essay 1. Target essay 1 කියන එක කරන්න. Target essay 1. We write here. Try target essay 1. Try target essay 1. I'll start the discussion in 3 minutes. 3. Now already an hour is gone. The time flies. Time flies. Already an hour is gone. And we have finished 1 essay and 5 MCQs. Right. For sure, you will get several graphs in the exam, right? And graphs and graphs. 10ක් around 10 graphs you will get, right? graph plotting දාම දන්නේ නැත්නම් ඒක පුළුවන් කරගන්න පුළුවන් අර වීඩියෝ එක බලුවා නම් හරි. මම graph plotting session එකක් කරා. අනේ graph plotting session එකේ වීඩියෝ එක බලන්න අනිවාර්යෙන් ඒකෙන් graphs ටික හදා ගන්න පුළුවන්, right? So you can easily get through graphs if you watch that. There I have discussed everything about plotting graphs for A-level physics. Combined maths වල graphs plot කරන්න හැටි නෙමෙයි. That is for A-level physics. Right. Target essay 1, huh? Target essay 1. Understand principles, understand theories, understand principles and understand theories. That's the key behind physics. Because physics is a conceptual subject, conceptual based, concepts based. Right? Concepts තමයි තියෙන physics වල. Right? නිකන් කටපාඩම් කළා, ඒ කියන්නේ parrot කළා. If you parrot it, you won't do even any question if you parrot it. Theories ඔක්කොම දන්නවා වෙන්න පුළුවන්, but you can't do any questions. Because you have to apply your analytical thinking, you have to apply your concepts with a given question, right? So that doesn't mean that you don't have to keep the theories in mind. You have to keep theories in mind, right? But most importantly, you have to know how to apply that particular theory. Most importantly, you have to know how to apply the theory. That's the thing, right? Physics පාඩම් කරලා කරන්න බැරි එකයි, right? මම ඊයේ theory class එකේදී මේ අර වීඩියෝ එකක් පෙන්නුවා ක්ලාස් එකේ මේ අර maths class එකක වීඩියෝ එකක් මේ O-level maths class එක O-level කියන්නේ grade 7 or 8 මොකක් හරි grade 7 it was නේ grade 7 maths class එකක වීඩියෝ එකක් පෙන්නුවා මේ maths පාඩම් කරනවා, right? It's a kind of a poem kind of a thing. They were parroting maths. ඉතින් එහෙම maths එහෙම කරලා grade 7 වල, right? කොහොම හරි O-levels නම් go through කරයි, but after A-levels, I mean if they are in A-levels, A-level science stream, most especially importantly, they won't go through, right? Because the thinking part of the brain is killed at that grade 7 itself. Right? In the පාඩම් කරන්න එපා ගණන් පාඩම් කරන්න එපා. පාඩම් කරන්න ඕනේ theory එක. Principles, concepts, theories, those are the things you have to know. That should be your knowledge. ගාන පාඩම් කරන්න බෑ. Now, as an example, if I take, let's say, the last question I discussed, the rotational motion one, මෙහෙම එකක් આવොත් මෙහෙම හදනවා කියලා මට පාඩම් කරගෙන යන්න බෑ, because always the question will be different from one another. We have to do something at the question, thinking of that given context, thinking of the given scenario, right? So if another question comes with the similar type, definitely I'm going to do this with this method කියලා එහෙම යන්න බෑ, right? So therefore always understand. That's the key behind this. Understand, right? In order to understand, in our knowledge, in our memory, we have to have the principles, theories, concepts, and everything in mind, right? Brain එකේ mind එකේ ඒක තියෙන්න ඕනේ. And we have to know how to apply that particular equation to match with the given scenario, to suit it with a given scenario, right? That's the thing. Okay, let's see. Question 1. Target is A1. Page number 9. Page number 9. Page number 9. Target is A1. Page number 9. Q1. Right. It says a balloon is moving upwards with 15 ms minus 1 uniform vertical velocity. Uniform vertical velocity. A stone is freely released from the balloon at a point 200 meters above from the ground. That's a good question. See, now let's say this is the ground, and the balloon is 200 meters above. Balloon is 200 meters above. Now the stone is released from rest. At the same moment, a separate stone is thrown vertically upwards with 15 ms minus 1 vertical velocity. Another stone, right? Let's say B, and let's say this is A. This is with 15 ms minus 1. And we have discussed this type of questions in the class and other question discussions as well. If any object is released from or detached from a parent body, if any object is detached from a parent body, it immediately acquires the magnitude and the direction of velocity of the parent body. Now, if this stone is released from a balloon is the parent body. So it immediately acquires the velocity, direction and magnitude of the balloon, of that parent body. So therefore, this gets a velocity 15 ms minus 1 upwards. It gets a velocity 15 ms minus 1 upwards. Initial velocity is not going to be 0 even though it's released from rest, as seen by a man on ground. Okay, now this motion is going to be, it will reach to a maximum point and it returns back. It will reach to a maximum point and it returns back. And this one also, it will reach its maximum point and it will return back, right? So these two will be the motions. These two are the presumed motions which are going to be as seen by a man on ground, A. As seen by a man on ground. What's the velocity of first stone? Man on ground, no, which means with respect to ground, with respect to earth, right? As seen by a man on ground, with respect to ground. What's the velocity of first stone? This one, 15 ms minus 1. A part 1, 15 ms minus 1 upwards. Part 2, what's the velocity of second stone? That is also same, 15 ms minus 1 upwards, right? Part B, what is the time taken by first stone to reach ground? First stone ground at once, I'm going to use S equals UD plus half AD squared for first stone. First stone, again A. For A upwards, S equals UD plus half AD squared, right? From beginning to the end, from the starting point to the end point. S is from here to here, no? So the displacement from here to here is 200 meters. Right? That is actually minus 200 because I'm using the equation upwards. Shall we use the equation downwards? That will be easy, no? Let's use the equation downwards. No point of using upwards, right? So if you are using upwards, that will be a minus 200. Now I'm going to use downwards. When I'm using downwards, that is plus 200, right? Then u is minus 15t, right? Plus half g is 10t squared. 200 equals minus 15t. This is 5, no? Plus 5t squared. This is divisible with 5. This is divisible with 5. 5 will cancel करा. 5 and this is 5 times 3. This is 5 times 40. All right. Now we have a quadratic equation. Get a quadratic equation. 0 equals t squared minus 3t plus minus 40. Then we have to factorize this. 0 equals, factors are t and t. What are the factors? 8 times 5 ganna puluwan, right? 8 times 5 minus 8 plus 5. Minus 8 plus 5. Which means factors are ne? Check factors. T equals 8 seconds or t equals minus 5 seconds. This is contradictory. So therefore, final answer t equals 8 seconds. Okay. So you can reach the final answer through a quadratic equation. Good one, no? That's a good one. You can reach the final answer through a quadratic equation. Clear? Clear? See, what's the time taken by second stone to reach down? See, time taken by second stone. මෙයානේ. එහෙනම් second stone එකට දාමු ආයෙමත් මේ equation එකම දාන්න පුළුවන්. For B, upwards S equals ut plus half at squared. S is 0 from here to ground again. Displacement is 0. U is 15. Then 15t plus half. Now upwards, no, minus 10t squared. Take this to the other side. This is minus 5, no? Then that becomes 5t squared. 5t squared equals 15t. 1t to t cancels. Then 5 to this cancels. T equals 3 seconds. T equals 3 seconds. Alright? T equals 3 seconds. Part D. What's the time difference between B and C? Very straightforward, very easy. D. Time difference. Time difference. So delta T equals 8 minus 3. 5 seconds. 8 minus 3, 5 seconds. 8 minus 3, 5 seconds. Okay. Part A is done. Hurry. Any questions? Any questions regarding part A? Is this clear? Tell me quickly. Okay, no questions, no? Shall we move on to part B? Okay, let me copy it down first. Let me copy this down. This goes over pulley and 15 newtons is hung here. And the pulley is connected to a pole like this. Okay. And right, that is on ground, something like this. And another mass is hung here, and this angle is given as theta. There's another mass hung here, 12 newtons. String is A, C, B. A, C, and B. Okay. Right. The AB string is fixed on a vertical strand and a pulley as shown in the diagram. A 15 newtons and 12 newtons weight. 15 newtons and 12 newtons weights are suspended at B and C respectively. Calculate the tension of the string of AC segment and the inclination theta to horizontal. Right. Two things. So this is an equilibrium. This is an equilibrium. Right. This is an equilibrium. So this is something from equilibrium. Right. So if there is an equilibrium, by considering equilibrium, see, now if there are forces acting on the string, I mean at the middle point of a string, then tensions of either sides are going to be changed. They are going to be different. So let me mark tensions from here. T1. If this is T1, this is also T1. This is also T1. Up to here, that is T1. And after that, that's a different segment. So let's say this is T2 and this is T2. And this one is also different, T3 and T3. Those are the tensions. Those are the tensions. Right. We need tension of the string AC and inclination theta. Right. Then AC again T2. This is what I'm seeking now. I need T2. I need T2 and theta. These two. We need T2 and theta. We need T2 and theta. We need T2 and theta. Hurry. If there is an equilibrium, consider equilibrium and write answers. I mean, get equations by considering equilibrium. Now, if I consider this equilibrium of 15, first I can find T1, right? So, what's the argument? Vertical equilibrium of 15. Argument is vertical equilibrium of 15 newtons. Okay. This is vertical equilibrium. Vertically upwards we have T1, vertically downwards 15. So one answer is here, T1 equals 15. Right? T1 equals 15. And similarly, we can do the same for this object here, 12 newtons. Right? Then vertically upwards forces equals vertically downward forces. Vertically upwards it has T3, vertically downward it has 12, which means T3 equals 12 newtons. Right? So first we can determine these two. Very easy. තක්ගාලා මේක හොයාගන්න පුළුවන්. හරිනේ? හරිම ලේසිනේ. තක්ගාලා මේක හොයාගන්න පුළුවන්. මේක හොයාගත්තා නම් මේ C කියන point එක equilibrium එකේ තියෙන point එක ගන්න. C is a point which is in equilibrium. Right? C is a point which is in equilibrium. Then it should satisfy the force equilibrium. By considering C, now we know from this a component comes. Now if this is theta, this is T2 sin theta. And this component will be T2 cos theta. Now consider C. This is by vertical equilibrium of, see, vertical equilibrium of point C. Vertical equilibrium of point C. Vertically upwards, we have T2 sin theta. T2 sin theta. Vertical downwards, 12. Right? So I will consider it as equation 1. And then similarly, horizontal equilibrium of point C. horizontally leftward forces equals horizontally rightward forces. Horizontally leftward forces equals horizontally rightward forces. Horizontally leftwards, we have T2 cos theta. T2 cos theta. Horizontally rightwards, T1. Only T1 because perpendicular forces are going to be neglected. We are dealing with vectors. Only T1 is here with the as a horizontal force. T1 is determined 15. T1 is determined, that is 15. 15. So let's consider it as equation 2. Now easily to get the inclination, divide these two. 1 over 2. 1 over 2. Then T2 cancels. T2 sin theta over T2 cos theta equals 12 over 15. Right? T2 to T2 cancels. And I'm thinking, tan theta equals 12 over 15 can it cancels by 5. 3 ne? That is 4 over 5. 4 over 5. So theta equals tan inverse 4 over 5. Theta equals tan inverse 4 over 5. Theta equals tan inverse 4 over 5. හරිනේ inclination එක හරි. හරි. Tan theta is 4 over 5. Theta is tan inverse 4 over 5. Since this is an essay question, this value of tan inverse 4 over 5 has to be determined. Right? මෙයාගේ value එක හොයලා දාන්න ඕනේ. Using natural tangents table. We have to find this value and put it. Right? Tangents බලලා ගන්න value එක. 4 over 5 කියන්නේ it's 0.8 නේ. එයාගේ tan inverse බලන්න ඕනේ. It's around 38 degrees 40 minutes. හරි. ඉතින් value එක ඔයාලා දාන්න වෙනවා. This is 38 degrees 40 minutes. මේක තමයි final answer එක. 38 degrees 40 minutes. Right. Then we need T2 ne? T2 tone. To get T2, now since the angle is known, use any of the equations. If tan value is known, which means sin value and cos value is also known. Right? See? To get the other answer, now what I know is tan theta equals 4 over 5. Tan theta equals 4 over 5. Now if we think of the triangle, tan theta is opposite side over adjacent side, no? So that is 4 over 5. Then what is going to be this? This is going to be x squared is 5 squared plus 4 squared, no? 25 plus 16. 25, 35, 41. So that is root 41. This is root 41. Right? Root 41 එකත් එතකොට හොයන්න වෙනවා. Now I'll get it from equation 1. Right? From 1, T2 equals 12 over sin theta. So T2 equals 12 over, now what is sin theta from here? Sin theta, opposite side over hypotenuse. Then opposite side 4, hypotenuse, root 41. So T2 is this is 3 root 41, and root 41 should be determined, should be found. Root 41 should be found and substituted there, right? Log solim balanna wenawa. Log solim balanna wenawa. There's no other option. Root 41 is 6.40. Where is it? Here. 3 times 6.40. Final answer 19.2. 19.2 newtons. Right. That's the final answer. Part C. Part C. So ask if there's anything up to here. Quickly copy down, and we are moving on to part C. Right, we are moving on to part C. Any questions? Sleepy? Huh? Sleepy there? Now it's 11:40. 11:40. Right? Term test ගාගන්න බෑනේ ඉතින් term test වල පාඩම් කරනවා නේද උදේ වෙනකන් around 2 3 4 5 හරිනේ. Let's go to part C. No questions? Right. Part C. A 70 kilogram mass of man stands on a balance which is fixed in an elevator that is moving vertically upwards direction. Okay. Let's do it here. That is fixed on an elevator. Stands on a balance. Right. So let's say this is the balance. This is the balance. And that person stands here. That person is on the balance. Right? Vertically upward direction. This movement is vertically upwards. The elevator starts its motion with rest and 3 seconds time period with 4 ms minus 2 acceleration. Finally, it becomes rest with a uniform retardation. Weight of the man was indicated as 490 when it is moving with retardation. Okay. All right. So this is a question from F equals ma, Newton's laws, right? Newton's laws question. So let's see, good one. I erase this. This is a good question from Newton's laws. Let's see. Newton's laws. Calculate the apparent weight of the man when the elevator is moving with acceleration. Okay, initially it's moving upwards with this 4 ms minus 2, no? Right? That is an acceleration. All right. So what you need to know is reading of a pan balance. Reading of a balance is the reaction on balance. Reading of a pan balance is the reaction on balance. Right? So this is the logic for this question. Right? Reading of a balance. Pan balance. Because if there's a spring balance, that will be different. Now this is a pan balance, no? If there is on the floor, that is a pan balance. If there is hung from a point, that is called a spring balance. Reading of a pan balance is reaction on pan. Right? Reading of a pan balance is reaction on pan. Dan nattang මේක තමයි logic එක. Right? Reaction on pan. එහෙනම් අපි මෙයාගේ reaction on pan හොයාගත්තා නම් හරියි. Reaction on pan කියන එක හොයාගත්තා නම් හරියි. Right? Now on this person a reaction acts, right? R, and its weight acts what the mass of 700 newtons, right? And equal and opposite reaction of this R will be on this balance. So which means if we calculate R, That will be the indication, that will be the reading of that particular balance. Right? R simply simply determine R, calculate R. See, for part 1, upwards, F equals MA. This is for man. For man, upwards F equals MA. Then R minus 700 equals M is 70 and acceleration upwards is 4. Acceleration upwards is 4. So R minus 700 equals, this is 280, which means R equals 980 newtons. So reading of this balance now is 980 newtons. Reading of this balance now is 980 newtons. 980 newtons. Right? Second one. Find the displacement. Find the displacement moving with acceleration. Starting from rest given. Motion with rest. Okay. Then upwards, S equals UD plus half AD squared. U is 0. Half. Acceleration was 4. And time 3 seconds time period. 3. Right? So displacement is, this cancels, 2 to 4 cancels, 2, 6 meters. 6 meters. Right? Part 3. Find the maximum velocity obtained by elevator. Right? So it says it accelerates and finally it becomes rest with uniform retardation. Then maximum velocity is at the final point of acceleration. Right? Maximum velocity is at, maximum V is at last point of acceleration. It is at last point of acceleration. Maximum velocity. So I apply V equals U plus AD upwards. Very easy. U is 0, A is 4, T is 3. So V equals 12 ms minus 1. 12 ms minus 1. 12 ms minus 1. Very easy. 4. Find the value of the retardation of the elevator. Find the value of the retardation of the elevator. Okay, now indication is given. Indication is given. Now, when it moves with the retardation, see, which means the reaction of this man on this man has been 490 and his weight is 700, we know, right? So upward retardation means that is a downward acceleration, no? So my is, I consider this is upward retardation, no? Upward minus A, so that is a downward positive acceleration. Considering that, use F equals ma again, right? Use F equals ma again. I'll use F equals ma downwards. This is for man. 700 minus or upwards or anything, any direction you can use. If you are using upwards, F equals ma for man 490 minus 700 equals 70 times A. Right? Then 490 minus 700 here, 210. 210 equals 70A, 0 to 0 cancels, A equals this minus 210. So A equals minus 3 ms minus 2. So value of retardation is 3 ms minus 2. Right? Minus 3 killing. Find the value of retardation of the elevator. Hurry. Find the displacement moved with uniform retardation. For that also, now for retardation time is unknown. Since the time is unknown, use this. V squared d equals u squared plus 2as upwards. V squared is 0. U squared is 12 squared plus 2. Upwards we have retardation minus 3 and s. Right? This is minus 6. Ne? So comes to this side 6s equals 12 squared 12 times 12. Then 6 to 12 cancels 2. So s equals 24 meters. S equals 24 meters. S equals 24 meters. S equals 24 meters. Okay, it's also finished. It's also finished. Any questions on this? May I say a prashna diyanadu? May I say a prashna diyanadu? Quickly. Any questions regarding that essay? Anything? Is it all clear? Can you explain the second part again? What do you mean by the second part? Displacement? This one? Displacement. Use S equals UD plus half AD squared upwards. S equals UD plus half AD squared upwards. Right? From the starting point of the motion until the end point of acceleration. Right? So displacement is S, and it says, the question says it's starting from rest. So U is 0, the part becomes 0, and acceleration is given as 4, and time is also given 3 seconds. Time just plug it and simplify. 6 meters. Plug it and simplify. 6 meters. Any other questions? No? All good? Shouldn't be 3 squared. Sorry about that. Sorry about that. And thanks. Thanks, I have missed it. 3 squared, 3 squared. Sorry about that. So that is 18 meters. Ne? Sorry about that. And thanks for raising it. Thanks for raising it. This is 9. 9 times 2, 18 meters. Right? 18 meters. Thanks for raising it. Right? That was a mistake. Okay? 18 meters. All good? All good? Right. Now, let's try a structured essay. Right? Okay, well, we types of questions discuss කරගෙන යනවා. එතකොට දැන් මේ discussion එක ඉවර වෙද්දී structured essays උත් practice කරලා තියෙන්නේ, essays උත් practice කරලා තියෙන්නේ, MCQs උත් practice කරලා තියෙන්නේ. So you will get an understanding about the techniques behind tackling these questions. Right? So go to structured essay 1. Try structured essay 1. Again, I'll give you 2 minutes and going to start. I'll give you 2 minutes and going to start. Do structured essay 1. Do structured essay 1. Right? Try structured essay 1 after the question. Right? Try structured 1. Try structured 1. I'll give you 2 minutes. Try structured 1. It says a metal sheet with a circular hole of radius d, something like that. Try it. Try structured 1. structured 1. Right, structured as a 1. Start structured as a 1. I won't give you much time, right? I'm going to start in 2 minutes, right? පොඩි ටයිම් එකක් දෙන්න නිකන් ක්වෙස්චන් එක රීඩ් කරගන්නත් එක්ක, right? ක්වෙස්චන් එක රීඩ් කරගන්නත් එක්ක තමයි ටයිම් එක දෙන්නේ. We are in structured as a 1, page number 6. Structured as a 1. Structured as a 1. Right, shall we start? A metal sheet with a circular hole of radius simple d is shown in figure. A, B, and D are lengths of a few centimeters, T less than 10 centimeters. Right, small lengths, T less than 10 centimeters. Thickness, thickness it is of several millimeters. Thickness of it is should be of it. Thickness of it is several millimeters. Okay. What's the most suitable measuring equipment to measure thickness of thickness T of the sheet? What's the most suitable measuring instrument? Right. Then several millimeters, no? To measure thickness, we have either vernier caliper or micrometer screw gauge. The most suitable one is micrometer screw gauge. For A, micrometer screw gauge. Micrometer screw gauge. Then B. What's the important experimental step to be practiced before the use of above equipment? We have to check whether we have to check for zero errors, no? Then we have to check whether what is coincided. We have to check whether the checking zero error, that is also enough. What's the important experimental step? Ne? We'll write a complete answer. We have to check the zero error. Make an instrument micrometer screw gauge. Micrometer screw gauge zero error check කරන්න කොහොමද කියලා. Right? Checking zero error by contacting anvil and spindle. See, the above measurements were taken by using a vernier caliper. Which parts of the measuring equipment are used to obtain each measurement? ABC වල parts ආනවා. For A is a length, no? So external jaws has to be used, right? External jaws. That's the outer length. External jaws. B කියන්නේත් outer length එකක්නේ. Same. External jaws. C. What is C? What was C? It should be A, B and D are few centimeters. It should be D, not C. Yeah? That's a printing mistake. It should be D, right? This should be D, not C. A, B and D. Make that correction in the question. This should be D. This should be D. So D is the diameter of this hole. That's the diameter of hole. That's an internal diameter. So therefore internal jaws. Internal jaws, right? Part D. What is the most suitable laboratory equipment to measure the mass of the metal sheet? Right? To measure masses, we have now, this is a small mass, no, not a big sheet, small mass. To measure masses, we have either triple beam balance or electronic balance or chemical balance. Most sensitive ones are chemical balance and electronic balance. Triple beam balance එකටත් වඩා chemical balance and electronic balance are sensitive, right? So therefore let's go with electronic balance. මේ දෙකම හරි. Electronic balance එක chemical balance එකත් කමක් නැහැ. Electronic balance or chemical balance. Electronic balance or chemical balance. E. Write an expression for the density of metal using the above measurements and the standard formula. Okay, write an expression for density. All right. Then what about the mass? We have to consider mass. Yeah, we'll consider mass and write the equation. No? It's given before. No? What's the most suitable laboratory equipment to find the mass? M. So M is introduced already. Now we can use mass. Density, right? To get density, first hand we need the volume. See, let's say volume is V of this. Let's say the volume is V. Let's say the volume is V, right? Volume එක දන්නවනම් density එක ලියන්න පුළුවන් නේ. Volume එක දන්නවනම් density එක ලියන්න පුළුවන් නේ. So find volume. Volume එක ලියන්න පුළුවන් මෙයාගේ. Lengths are A and B නේ. So volume of the outer sheet is A times B times thickness, ABT, right? A times B times thickness. Thickness was introduced as T. Right. Making subtract කරලා දාන්න 5r squared. So that is 5r of that is d over 2 නේ, d over 2 square. Right? So let me write in this way. මෙයාගේ T එක එළියට දාන්න ලියමු. T can be taken out. This times T, right? So final volume is AB minus 5d squared over 4 times T. If volume is known, density can be determined, right? So density is, we know, rho. Rho is mass or volume. So density is that M over this volume, that is AB minus 5d squared over 4 times T. This is the final answer. F. This is the final answer. Okay? This is the final answer. Part F. The measurements obtained at several places for the thickness of the metal sheet are given below. 3.50 millimeters, 3.51, 3.52, 3.51, 3.53. What's the least count of the equipment? Right? If the measurements are taken to 2 decimals, which means least count is also to 2 decimals. So least count of the instrument is, if part 1, no? Least count of the instrument, least count equals 0.01 millimeters. 0.01. Part 2, calculate the mean thickness of the sheet. Mean thickness. Right? May would values ke mean gun. Mean thickness. Mean thickness will be 3.50 plus 3.51 plus 3.52 plus 3.51 plus 3.53 over how many readings? 5 over 5. Right? मैंने value वेग गन लो. Simplify it. 3.514. So that is 3.514. 3.514. So we can keep the answer as 3.51 again. Right? If it is rounded, we can keep it to 3.51 again. Check whether the values are correct. 3.51 I got. Right? I got 3.51. Check whether the values are correct. Next. How many decimal places can be included in your answer? Explain the reason. How many decimal places can be included in your answer? Now that is from the least count of the measuring instrument, because we know any measurement that we take from an instrument is in accordance with the number of decimal places in the least count, right? So therefore, how many decimal places? No, only two. Two decimal places. Two decimal places. Asking the reason. Ne? Explain the reason. Because least count of the instrument used has only two decimal places. Has only two decimal places. This is the final answer, right? So if the least count has two decimal places, which means for the final reading also, we can only have two decimal places, only two decimal places, right? Any questions from this? First structured essay we discussed, right? So when we are writing structured essays, we have to write to the point answers, to the point. To the point answers. They should be concise answers. Up again, short and sweet answers. They should be short and sweet answers. Concise, to the point answers. Any questions? Or is it clear? Quickly. Any questions or is it clear? Quickly, tell me, quickly. Clear? Clear, right? Clear? Right. Hari, structure is a good kara. Now again, to break ice, let's try few MCQs. Try the MCQs from 5 to 10. Try the MCQs 5 to 10. Try MCQs 5 to 10. 5 to 10. 5 to 10 MCQs से try करा. Yes, good. Try MCQs 5 to 10. Try 5 to 10 means 6 to 10. Ne? Try 6 to 10. Try 6 to 10 MCQs. Try 6 to 10 MCQs. Quickly. I'll start again in 4 minutes. 4 minutes. Tagala MCQ sticker. Try it quickly. Try it quickly. I'll start in 2 minutes. Huh? I'll start in 2 minutes. Okay. Let's see. Let's see. MCQ 6. The cricket ball leaves the bat with a velocity of 60 ms minus 1, inclined 30 degrees horizontal. After being hit, the ball lands on a distant roof as shown in the figure. If time taken to land on the roof by ball is 5 seconds, height of the building is. Okay, so directly, right? See, question 5. Right, question 5. Directly, sorry, 6, ne? Question 6. Use S equals UD plus half AD squared upwards. S equals UD plus half AD squared upwards. Right? S will be H. Then U is 60 sine 30 upwards. No? 60 sine 30 plus half. We are using the equation upwards. So G is minus 10. Time is 5. Sorry, here 5. And this is 5 squared. Simplify this. H equals 60 sine 30 is half times 5. And this is minus 5. This part becomes minus 5 into 5 squared. So this cancels 30. Again, 30 times 5 is 150 minus 25 times 5 is 125. So H equals 25 meters. H equals 25 meters. For 6, answer 3. For 6, answer 3. 6, 7, 8, 9, 10. For 6, answer 3. Right? 7. A box of mass 5 kg. A box of mass 5 kg, which means weight is 50 newtons. Reaction next 5 kg is kept on a horizontal surface. Coefficient of static friction between the box and the surface is here mu equals 0.3. Frictional force acting on frictional force acts when the horizontal force 10 newtons is applied on it. Okay. Now a 10 newton is applied. Friction is asked. So first calculate what the limiting friction of this surface is. F equals mu r. Right? So F equals mu is 0.3. R is 50. Means 15 newtons. So this is the limiting friction. This is not the present or the current friction. This is limiting friction. Limiting friction is the maximum possible friction in between these two surfaces. This is limiting friction. Limiting friction. Right? Since the applied force is less than limiting friction, right? So you have to know this variation. Now I'm referring to this variation between friction force and the applied force. This is the variation of friction with applied force. Right? So I'm referring to the variation. Limiting friction is here. Limiting friction is here. This is limiting friction. Limiting friction. And this region is called the self-adjustment region. Self-adjustment. Right? Now since this is argument very important, since the applied force is less than limiting friction, that is in the self-adjustment region. Self-adjustment region means friction will be self-adjusted as it to match with the applied force. So therefore, friction here is also 10. Therefore, friction equals 10 newtons. 10 newtons. Answer 4. For 7, answer 4. For 7, answer 4. 8. Question 8. A person rotates a ball in a horizontal circle of radius r1 with an angular velocity omega 1 as shown in the figure. If he reduces the radius of circle to r2 without applying an external torque, new angular velocity is given by omega 2 is given by. Right. So if there are no external forces, angular momentum is constant. Then I1 omega 1 equals I2 omega 2. Moment of inertia, I can be expanded as mr squared if the object rotates around an external axis. Now this is an external axis, right? The person is an external axis for the rotating ball, right? So therefore, I can be expanded as, see, I is mr squared. I is mr squared. For first case, m r1 squared omega 1. For second case, m r2 squared omega 2. M to m cancels. But we need omega 2. Omega 2 equals r1 squared over r2 squared times omega 1. Right? then omega 2 equals R1 over R2 whole thing squared omega 1. Second one, for 8, answer 2. Question 9. Question 9. Question 9. Three liquids of different densities, rho 1, rho 2, and rho 3 are in a U-shaped container. Which of the following equation correctly represents the relationship among densities? Right. Three liquids are here. This level is same. 15 and something like this. Right. 15 centimeters, 10 centimeters. Then this has to be 5 centimeters. Densities are rho 1, rho 2, and rho 3. Right? So this is the interface. See, this is the interface. This is the interface. This is the interface. So let's say this point is point P and this point is point Q. Pressures at the same level of the same liquid are equal. That is proved in hydrostatics. In hydrostatics, we prove that pressures at the same level of the same liquid are equal. Then I can argue as pressure at P equals pressure at Q. Pressure at P equals pressure at Q. Now it is open to atmosphere now. P naught tax, P naught tax. Then PP is P naught plus H is 15 now. 15 rho 1 G. H rho G because pressure is liquid pressure is H rho G. PQ is P naught plus 10 rho 2G plus 5, sorry, rho 3G, 5 rho 2G. P naught to P naught cancels, G to G cancels. This can be cancelled with 5. So 3 rho 1 equals 2 rho 3 plus rho 2. 2 rho 3 plus rho 2. 2 rho 3 plus rho 2, answer 1. For 9, answer 1. For 9, answer 1. Right? Question 10. A solid cylinder rolls to the right on a rough horizontal plane without slipping. Okay, this rolls to the right without slipping. Direction of velocity at point O on the circumference is right. It rolls without slipping. Rolls to the right. Okay. Now it is on here now. Point O is somewhere here. Point O is somewhere here. Right? Okay. If you need to get the velocity, if you need to get the direction and magnitude, no, not the magnitude, direction, only direction. Right? If you need to get the direction, we know rolls. Okay. Now it has means it will have a horizontal velocity, because rolling motion is a combination of rolling is a combination of linear plus rotational. Rolling is a combination of linear plus rotational. Then it will have a linear velocity like this. So that same linear velocity will be on this point like this. And other than that, due to rotation, it will get a tangential velocity due to rotation. So if it is rotating in this direction, as it is perpendicular with this, right? So this will be Vt, tangential velocity. එහෙනම් මේ දෙකේ resultant එක තමයි හොයන්න ඕනේ. Direction of velocity at point O in the circumference is. හරි. එහෙනම් මේ දෙකේ resultant එක. So that resultant goes in between. This goes in between. Then from the given answers, what's the pick? B or C? D is perpendicular, right? You can connect it and see D is perpendicular. B එක horizontal වෙලානේ තියෙන්නේ. Should be C නේ. Should be C. ඒ කියන්නේ OC. Answer 3. For 10, answer 3. For 10, answer 3. It cannot be horizontal. Make a horizontal. It should be between horizontal and this direction. It should be between horizontal and the perpendicular direction. Horizontal and perpendicular direction. So that is C. Answer 3. Answer 3. Right. So quickly ask if there's anything to clarify from these MCQs. Quickly ask if there's anything to clarify from the MCQs. From these MCQs. Anything to clarify from the MCQs? No? All good? Harder. So what about now? Sleepy? Now it's 12:20. 12:20. Right? So there are a few more questions remaining. Are you sleepy? No, ne? Right? Now you are matured A-level students, huh? You are matured A-level students. Now, when we are close to the exam, now it's not a time to sleep and all that. I mean, you can't do as you did in O levels, right? Not sleepy? Okay. Next question. Alright, next start karamu. Go to third structured essay. Try structured essay 3. I'll give you 2 minutes again. Try structured essay 3. Try structured essay 3. Try structured essay 3. Start. Try structured essay 3. Start. Try structured essay 3. So put to chat if there's anything. Can you explain the 7 and 10 again? 7 and 10. What was 7? 7. In 7, now always from the equation F equals mu r, what it gives is limiting friction only. What it gives is limiting friction only. The method in Dabu limiting friction. Limiting friction is the maximum ever friction, maximum possible friction for the system. Maximum friction that is 15. But the applied force is now 10. In self-adjustment region, friction adjusted with applied force as it is to match with applied force. So if there is less than 15, which means friction is now at self-adjustment region. So that is adjusted to applied force. Applied force is 10. If applied force is 10, friction is also 10. And about question 10, what is question 10? This one. About question 10, now if there is an object which is rolling, there are two velocity components acting on such objects. One is from the linear velocity, one is from the linear motion, and the other velocity component is due to the rotational motion. For linear component, now if it is moving horizontally rightwards, so linear velocity is horizontally rightwards. That same linear velocity is at any point of this object, right? That linear velocity will be at any point of this object. Now, therefore, at here also there is horizontally linear, like this, horizontal and linear. And when it comes to rotational velocity, direction of rotational velocity is it's tangential. Now, if you connect the center with this is perpendicular because always tangential velocity is perpendicular to the center. So this is the direction of tangential velocity. Resultant of these two, resultant velocity of these two should be something in between. Resultant velocity of these two has to be something in between. Horizontal එකයි මෙන්න මේ tangential direction එකයි in between තමයි එහෙනම් resultant velocity එක තියෙන්න ඕනේ. They are asking velocity. Velocity means resultant velocity. හරි? එතකොට the only answer which is in between these two is it was C. So that's why I selected OC. Okay? Right? So try structured essay 3. I'll start in a short while. Try structured essay 3. Structured essay 3. Try that one. Try structure is 3. I'll start in 2 minutes. Alright. Body time map දෙන්නේ question එක go through කරලා body idea එකක් ගන්න discussion එකට කලින් නැත්නම් මට එකපාරට discuss කරන්න පුළුවන්. right body idea එකක් ගන්න question එක ගැන. right get some idea about the question. right go through කරලා body idea එකක් ගන්න. එතකොට discuss කරද්දී ටක් ගාලා බලන්න පුළුවන්. So ask if there's any questions, anything to clarify from the things we discussed so far. Okay. Okay. Let's see. Question 3 ne structured essay 3 page number 8. Page number 8. Page number 8. Page 8. Structured essay 3. Okay. Two graphs are given. V is measured in ms minus 1. Time is measured in seconds. This is given as 11 and this is 4. Okay, let's see. What's the velocity time graph of the player A who is running 100 meters event is shown below. Okay, then it has to be this. Label this as A, label this as A, and label this as B. That's actually missing. Label this as A and label this as B. Because in part 4 it says player B is running with uniform acceleration. No? So this is B. Right? Question එක read කරලා ඒක identify කරගන්න පුළුවන්. Right? Question එක read කරලා ඒක identify කරගන්න පුළුවන්. But let's assume I have given it A and B. Right? What's the acceleration of the player? Now we are still in player A. Then acceleration of player A is this one. Let's consider this total angle as alpha. Right? Part 1. So tan alpha can be written as gradient equals tan alpha. Tan alpha can be written as 11 over 4. Right? So that is equal to acceleration. So acceleration will be 11 over 4. What's the value? 10 over 4 again 2.5. So rather than I 2.5 ne? So 2.75 ne? 2.75 ms minus 2. Second one, what's the displacement of him at the end of 4 seconds? Displacement is given by the area. Displacement equals area under curve. Right? So up to 4, area under curve is, that's a triangle, half times 4 times 11. That is 22 meters. 22 meters. 22 meters. Part 3. What is the total time taken by player to finish the game? What is the total time taken by player to finish the game? Hurry. Up to here, the displacement is only 22 meters now, right? Which means now if he is finishing somewhere here, right? If he is finishing somewhere here, total time what's the total time taken? Let's say it takes time t to finish the race for A, right? It takes, let's say, time t to finish the race. Now, if this is 22, this displacement has to be 100 minus 22, right? If there is 22, the displacement here has to be 100 minus 22. What's the value? 78 meters. Again, same area, same argument. Right? Let me do it here. Part 3. Area equals half times. Sorry, not half. Square, right? That's a rectangle. Area of the rectangle, not a triangle. Area of the rectangle. Area of the rectangle is, it should be 78. T minus 4 times height is 11. It has to be 78. And 78 equals t minus 4 times 11. Right? So t minus 4 equals 78 over 11. What's the value? 78 over 11. 7.09. Right? So which means t minus 4 equals 7.09. T equals 11.09 seconds. T equals 11.09 seconds. Right? That's a good part. The displacement of him up to 4 seconds is only 22 meters. And initially it has given he is running 100 meters. Then this should be the remainder. 100 minus 22, 78. Then area of this rectangle has to be that 78. Area of the rectangle has to be 78. Area of the rectangle has to be 78. Area of the rectangle has to be 78. Next one. 4. About player B now. It says player B running with uniform acceleration at the end of 7th second, the player A was passed by the player B. 7th second. Hurry. Draw the velocity time graph of player B on the above given axis. Wow. Now there's a small mistake in the question. The mistake is that graph is already given. So this is the given graph. That graph is already given, na? That graph is already given. Right? It should be this. So this is then part 4. Part 4. This is part 4. Okay, now it's done. Then part 5. What's the displacement of players at the end of 7th second? Okay. Now the 7th second is somewhere here. See, 7th second should be somewhere here, no? Right? 7th second, 7th second. Displacement of players. Then we can use either this triangle or this trapezium. But acceleration is unknown yet. Acceleration of player B is unknown yet. So we will go ahead with the trapezium. Right? Displacement after 7 seconds. No? Then that is the area of trapezium. Area of this trapezium. These sides will be 3, 7 minus 4 3. Then 3 plus 7. 3 plus 7 over 2 into perpendicular height 11. 5 times 11, 55 meters. 55 meters. Right? 55 meters. It has again, find the velocity and acceleration of player B at this moment. Velocity and acceleration at this moment. So let's assume that velocity of player B as u, right? And let's assume the acceleration as a, right? To write acceleration, we can use this angle. Let's say beta. Right? Tan beta tan beta equals opposite side is a. U. Opposite side is u. This is u. Opposite side is u over 7. U over 7. So this is acceleration, no? So a equals u over 7. This is one of the equations. To get velocity, we can write another equation using what? Area. Area of triangle equals, it should be same, no? Because they are passing each other. That is 55. Area of triangle can be written as half times 7 into u. Half times 7 into u equals 55. Okay, then from here, u is determinable. U will be 55 times 2 again, 110 over 7. U is 110 over 7. What's the value? 110 over 7. 15.71. 15.71. Now, from equation 1, we can find acceleration. I'll erase this. From equation 1, now you can get acceleration. From equation 1, you can get the acceleration. See, from 1, we know acceleration is u over 7, no? So plug that value of u is 110 over 7. U is 110 over 7, then over 7. So acceleration is 110 over 49. 110 over 49. 2.24. 2.24 ms minus 2. 2.24 ms minus 2. Next one. Velocity and acceleration. What's the difference between finish times of two players? What's the difference between finish times of two players? Finish time finish time of B should be determined. Finish time of B should be determined. He is also running 100 meters, no? B is also running 100 meters. B is also running the same 100 meters, same race 100 meters. එහෙනම් මෙයාගේ triangle එක 100 meters වෙන තැනට time එක හොයාගත්තා නම් හරිනේ. Right? Last part 7. For B's triangle, it should be 100 meters at the end. It should be 100 meters at the end. Then half times acceleration of B, half times velocity of B is u into time එක දන්නේ නැනේ. U is known. Let's say time is t dash equals 100. U is known. We have the value. So half times I will substitute u as the fraction, because if there's anything to cancel, it will cancel. 110 over 7. T dash equals 100. See, 0 to 0 cancels. Right? So T dash is subjected. This is 14. Then 140 over 11 කියලා එනවා. 140 over 11. 12.72. 12.72 seconds. 12.72 seconds. So what was the question? What's the difference between times? Difference between times. Then delta t. Therefore, delta t equals. Therefore, delta t equals. Therefore, delta t equals. Therefore, delta t equals. What was the total time of the previous one? I have erased. I have erased. Anyone? Quickly. What is the total time of the first player? What was it? 11 point something ආව 12.72 minus part 3 එකට ආපු answer එක මොකද්ද? Anyone? Quickly. So I have erased. What was the answer for part 3? Quickly. කවුරු ටක් ගාලා දාන්න chat එකට. කවුරුවට chat එකට දාන්න මොකද්ද part 3 එකට ආපු answer එක? 11.09. Thank you. 11.09. So time difference is between these two. 12.72 minus 11.09. 1.63 seconds. That is only 1.63 seconds. Right? 1.63 seconds. So which means now A has won the race. A has won the race. A has won the race, and B is behind. 1.63 seconds behind. That's all. Right. Okay. Any questions from this? Quickly. Any questions from this structured essay we discussed? Now, so far we have discussed 10 MCQs, 2 essays, 2 structured essays. Right? So far we have discussed 10 MCQs, 2 essays, 2 structured essays. Right? Anything up to here? All good? What about now? Sleepy there? Huh? Sleepy there? Not there? Quickly. Please engage. Now I'm talking here alone for around 3 hours. Yeah. Now for around 3 hours. Now it's just 15 minutes less than 3 hours since I started talking. Right? So put something to chat box and engage. Once again, students. Once again. No questions? Can you explain 1 and 6 again? 1 and 6. What was 1? Acceleration of the player. Acceleration is given by gradient of velocity time graph. That was the argument I used, right? Acceleration is given by gradient of a Vt. Acceleration is given by gradient of Vt, gradient of velocity time graph. Acceleration is given by gradient of velocity time graph, right? Then 6 6. Part 6 කියලා කියන්නේ find the velocity and acceleration. Same thing. Acceleration එක consider කරන්න එයාගේ gradient එක ගන්න, right? Respective curve of B is that one. So I considered the gradient as the angle as beta. So gradient එක කියන එක ලියන්න පුළුවන් m as either delta y or delta x or tan theta. So if there is beta, it can be written as tan beta, right? Acceleration is given by tan beta. It has a considering the distance, I wrote the area. So then from that we got 2 equations, and by solving these 2 equations we achieved these 2. Correct? Yeah? Okay. Now let's go to another essay, and when it comes to your term test this time, term 2, probably you will get an essay from hydrostatics or hydrodynamics, or fluid dynamics or hydrodynamics, right? So therefore we'll discuss this hydrostatics question, right? Go to essay number 2, essay question 2. I'll give you 3 minutes again to try the question. Essay 2, right? Try essay 2. Try essay 2. Try Essay 2. Try essay 2 quickly. 2 minutes. Write quickly. Try to do something that you can do. Try to do something. මොනවාරි question එකේ ඔයාලට කරන්න පුළුවන්ද කියලා තනියෙන්. Before the discussion. Before the explanation. Try you could do something. That's a good essay from hydrostatics, Archimedes law, Archimedes theorem. Okay. Essay 2. Boat services are there on the waters where the tourism activities are done for the entertainment tourist. Done for the entertainment of tourists. There are tubes filled with air is hung around the boats. The engine fixed at the back generates the power to move the pedal by burning fuel. The mass of the boat without passengers is 6,000 kilograms. 8 people each weight 70 kilograms can be loaded maximum. The air-filled tubes immense in water to provide the ability to load additional people on the boat. The pedals attached to the engine of the boat push the water backward. and obtain the force to move the boat forward. And extra work should be done when the paddles are rotated to push the water. Due to the hydrostatic pressure, the effective area of the pedals is 0.05 square meters. Density of water is 1000. Okay, first one. What are the requirements to be fulfilled to float boat on water? To part 1. Right, this is page 10. Question 2. What are the conditions to be satisfied by the boat to float on water? So that is the law of flotation. That is law of flotation. So in law of flotation, clearly we have two conditions satisfied by the object when it floats. Right? First one is upthrust equals, first condition, no? There are two conditions. First one, upthrust should be equal to, we have to write in words, upthrust should be equal to weight. Upthrust should be equal to weight. And second condition is center of buoyancy and center of gravity has to be on the same vertical line. Center of buoyancy and center of gravity should be on same vertical line. Should be on same vertical line. Part 1, part 2. That is totally from law of flotation. The law of flotation conditions law of flotation right? Law of flotation. What is law of flotation? If an object is floated in a static incompressible fluid, upthrust acting on the object equals weight of the object, and center of buoyancy and center of gravity of the object should be on the same vertical line. So I use that. Conditions sketch the forces acting on empty boat. Sketch the forces acting on empty boat. Okay. Upthrust acts and mg acts. That's it. Upthrust and mg. Upthrust and mg. 3. Find the upthrust on the boat when 8 people are on it. Okay. So we know upthrust equals mg. We know u equals mg. So upthrust equals 8 people are on it now. Find the upthrust when 8 people are on it. So boat without passengers 6,000. Total M 6,000 plus 70 times 8 G. Simplify this. 56 no? 11,600 11,600 newtons. 4. Harness simplification 11,600 because this is 1,160. Yeah, 11,600 K now. Yeah, 11,600. Then on next one. 4 part A. 4 part A. Find the minimum force to start the motion. Find the minimum force to start the motion if there is an extra resistive force of 0.6 newtons per kg on the boat, right? Minimum force to start, then that will be the same resistive force. Resistive force that's the minimum force to start. Same resistive force in opposite direction will be the minimum force to start. Then minimum force to start will be resistive force is 0.6 newtons per kilogram. 0.6. 1,160 kilograms. And simplify 1,160 times 0.6. 696. 696 newtons. 696 newtons. 696 newtons. 4. Sorry, 4 B, part B. Find the speed of the speed of water pushed back to obtain the minimum force above. Right. Find the speed of water pushed back to obtain the minimum force above. Right. For that, we have an equation for force due to liquid as F equals rho A V square. F equals rho A V square. F is 696. This is a proved equation. That's why I am using the equation at once. This is a proved equation. Rho 1000 and A is pedals effective area 0.05 kilo 0.05 V squared. From this we have to simplify V squared. Okay. Then V squared equals, this is 696. This is 5 times 10 to the power minus 2. 5 times 10 to the power minus 2. So minus 2 cancels. 50 remains. 50 remains. This is cancelable by 2. 696 again 348. So this is 348 over 25. Now I have to do the log simplification. 25 is a known square root. 25 is a known square root, but 348 is not a known square root. Right? Simplify karaganna puluwan by 4. 4 in 348 divide by 1. Right? By 4 it divides. So it can be written as 4 times 87 over 25. So final answer will be V, then 2 over 5 root 87. This has to be simplified. Has to be simplified. That's a log simplification. That's a log simplification. It comes to 3.73. It comes to 3.73 ms minus 1. 3.73 ms minus 1. 3.73. Right? That's a log simplification. You have to do in the exam, at the exam. 5. Part 5, part A. 5 part A. Find the rate of work done by pedals. Rate. We can write P equals FE. No? Calling questions use P equals FE. Rate of work is a power. Rate of work is a power. Rate of work is a power because rate is power. Rate is work over time. Anything over time is a rate. So work over time is a rate. Work over time is an energy over time. That's a power. P equals FE. So FE is 696. V is 3.73. Simplify this. 696 times 3.73. So power is 2596.08 watts. Simplify and see. If the efficiency of the engine is 40%, find the energy that should be given to it during that time. If the efficiency of engine is 40, find the rate of hurry. So this is the output then. This is the output. And output equals input times just 40% only. Right? Because it says if the efficiency of the engine is 40%. The engine again output 40%. Right? And that output has been this. So output is input times 40%. You are asked to find the efficiency of the engine. Sorry, you are asked to find energy that should be given to it during that time. Right? Energy should be given during a time, no? That's a power. Energy should be given during a time. Right? That's a power. And make a one there. So this is P out, this value. So let's say this is P in times 40%. This. So P in equals 25,000 this over 40. Simplify P in. It says 6,490.2 watts. 6,490.2 watts. Right. Right. Next, part 6. We are in part 6 now. The boat rides safely by immersing all 6 tubes hang around the boat up to the water level when the boat comes to an area with air bubbles. Right. If the effective density of water in that region is 800, right? So you know that when air bubbles are mixed to water, we say it as the effective density because density decreases. Right now it's 800. Find the extra volume needed to be sunk. Okay. All 6 tubes are immersed. Ne? When the boat rides safely, all 6 tubes are immersed and hang around the boat. Find the extra volume needed to be sunk. Okay. So which means upthrust remains same because mg remains same. Right? See? So upthrust remains same. Upthrust can be written as V rho g, no? Let's find the volume sunk in the first medium first. Right? So let's say V1. Then V1 rho 1 g equals mg. G to G cancels. V1 කියලා අපි එක හොයාගමු. It was 1000 before. And M was this much. Where? M here. 1180. So V1 is 1.16 cubic meters. So we can do the same for the second medium. U equals mg again. Then V2 rho 2g equals mg. G to G cancels. V2 times rho 2 is 800 now. Rho 2 is 800. Ne? Rho 2 is 800 equals M is same. So V2 is 10 cancels 116 over 80. 116 over 80. 1.45 කියලා එනවා. 1.45 cubic meters. Hurry. What's asked? Find the extra volume to be sunk. No, extra volume. Now, volume sunk in the second medium, effective density medium is 1.45. Volume sunk in the first medium is 1.16. You know, make the difference again. Find the difference of these two. So delta V is V2 minus V1. 1.45 minus 1.16. What's the value? 1.45 minus 1.16. 16 again 2636 29 0.29 cubic meters. 0.29 cubic meters. 0.29 cubic meters. It's a good question. It goes with a nice flow. Right? Connects to law of flotation, Archimedes theorem. Right? Okay, last part. If tubes give 60% of the extra volume, find the volume of a tube. Right. Then how many tubes over here? It was given neither. 8 people and how many tubes? Is it given? It's given no? 6 tubes. In part A, it's given 6 tubes. 6 tubes, right? Okay, now what's given? They say if tubes give 60% of this, again, now volume of a tube can be written as, let's say, volume of a tube. Now from this 0.29, from this 0.29, 60% is for tubes. Huh? From this 0.29, 60% is for tubes. Find the volume of a tube, no? Find the volume of a tube. We have 6 tubes. So main tubes volume mega. If we need one tube, again divide by 6. Right? So this cancels, 6 to 6 cancels, and 0.029 cubic meters. Volume of a tube is 0.029 cubic meters. Volume of a tube is 0.029 cubic meters. 0.029 cubic meters. Okay. Anything to clarify regarding that question? Anything to clarify? What about it now? What about now? All good? Is it clear up to here? Is it all clear up to here? Is it all clear up to here? Students? Again. Is it all clear about the questions we discussed? Now we have finished 3 essay questions, 2 structured essays, and 10 MCQs. Is it all clear? Yeah, quickly. Yeah. Okay then. Okay. The remaining questions are 10 MCQs are remaining, right? Listen, 10 MCQs are remaining from 11 to 20. 10 MCQs are remaining plus 1 structured essay from micrometer screw gauge is remaining. Question 2, right? So try the remaining 10 MCQs and the remaining structured essay on micrometer screw gauge as well before going to the exam, right? The questions they got try kalla balala yanda, and if you got any questions about those questions, feel free to ask, right? Feel free to ask. So I'm going to end up the session here. Any questions before winding up? Any questions before winding up? So I hope you got something, because definitely you should get something, because we have discussed all types of questions that will be useful in your coming up term test, right? All these types of questions will be useful in your coming up term test, right? So what about it? How is it savvy? Or can we do another question? Can we discuss another question? Or do you want me to stop? Do you need me to stop? Tell me. Tell me. Okay, again. Now it's 1:12. 1:12 a.m. in the morning, right? So by far we have finished. By far we have finished 3 full essay questions, 2 structured essays, and 10 MCQs. Arne? Again, how questions discuss karna ada nattang? What is it? Sleepy, tired, exhausted? Modaladi? Huh? Any feedback? Any feedback? Any feedback? Any feedback? Settled? Put it into the chat. Put it on the chat. You are so silent now. What does that silence mean? What does that silence mean? Hurry, okay. All right then. Now it was around 3 hours and 15 minutes of time to discuss these questions. It got around 3 hours and 15 minutes of time. Right. So I'll finish this session here. ඉතුරු වෙච්ච question එකයි MCQs ටිකයි කරලා බලන්න. Right. And face your term test well because I conducted this session exclusively for 26 term test. 2026 A levels term test, second term test coming up. Right. If there were students who didn't join the live session, who were not able to join the live session, if there are your friends or someone, ask them to watch the recording at least and go to the exam, right? Because definitely, for sure, this might be useful, this will be useful, right? So ask them to watch the recording and go, right? Okay then. So that's it then for today. Good luck with your term test, right? Good luck and good night, goodbye, study hard, right? Goodbye. No any questions? That's it. If there are no any questions, that's it. So if you have any questions, you can ask and leave. All right then, no questions, no? Right. Good night and see you all in the next class, right? See you all in the next class. Good night. Okay, goodbye.